let's look at this problem. It says to find ln of 24. Now, I am well aware that you could plug ln of 24 into your calculator and get an answer. However, that's not what this problem is testing. This problem actually is testing if you know the properties of logarithms and how to use them. So let me show you what I mean by that. Instead of writing ln of 24, I'm going to break 24 down. So I know that 24 is 2 times 12. And I can break 12 down as 2 times 6. And then I can break 6 down as 2 times 3. So I basically just factor treed 24. And now I can rewrite this like that. And now I can use my properties of logarithms. First one, I know that multiplying is going to turn into addition. So I'm going to change those into addition. Second, I know that if I have an exponent, I can move it out in front. So let's move that exponent in front. Now I can start to use these. I know that ln of 2 is 0.6931. Here, let me use some different colors. So I'm going to replace ln of 2 with 0.6931. And I know that ln of 3 is 1.0986. So I'm going to change ln of 3 out to 1.0986. And then that is what I'm going to type into my calculator. 3 times this plus this. And when I put all that out, I get 3.178. So if you were to type ln of 24 into your calculator, this is the answer that you should get. Now let's talk about why you can't just type ln of 24 in. I know you can, but if you see this problem on an exam or a final, it's not testing that you can just type it in and get an answer. It's testing, do you know how to use the log rules? So, if you see a problem like this on your test, and you do not actually show your work, I am not going to give you any points. Because I'm not looking for this. I am looking that you know how to do all of that. That's the important part. So, with that problem, let's try another one. Let's look at example 8 and example 9. Now, something I'd like you to notice about these two examples first is the wording. Example 8 says we want to expand and simplify. So in example 8, I'm not solving for anything. I shouldn't get an x equals answer. All I'm doing is expanding these logarithms. So let's look at what we can expand. If I look at this one, the first thing I notice is I've got some multiplication happening here. So I'm going to start by changing that multiplication into addition. Next thing I notice, I have an exponent that I can bring out in front. So let's do that. Now, there is actually one more thing I can simplify in this, and that is this logarithm. Now, the beauty of 1050 is that there is no part of your test that is non-calculator. You can use your calculator on every question on the test. So if you have a logarithm and you come up to one like this and it's just numbers, if it has letters, you can't plug it in. If it's all numbers, plug it into your calculator and see what you get. If you plug this in and it simplifies to a pretty number, so like a whole number or a nice fraction, then simplify it. But if you plug this in and it does not simplify to a pretty number, so it's a really long, ugly fraction, don't simplify it. Leave it alone. So I'm going to take this number, plug that into my calculator to see what I get. And I know that I'm going to get a -1. That is a really pretty answer. So I'm actually going to change that to that -1. It's a nice whole number. And there, I'm done. I took this one logarithm and I expanded it to multiple logarithms and then simplified everything that I possibly could. Now let's take on a little bit of a harder one. B. Now, I'm going to get you started on B, and then I would like you to pause the video and try to finish this one on your own. So the first thing I'm going to get you started on is we have to change that root into an exponent. We can do that using our properties of exponents that we talked about, where the number inside, or I shouldn't say the number, the exponent inside becomes the numerator, and then the root number outside becomes the denominator. The reason I'm going to do that is because now that it's an exponent, I can bring it out in front using my log rules. So, knowing that, I would like you to pause the video, try to simplify this logarithm as much as you can using the log properties we came up with, and then when you're done, come back to check your answer and see how you did. Let's see how you did. So, first thing, I brought the 1/3 in front like we talked about. Then I noticed this division, so I turned that division into subtraction. Now notice I did carry the 1/3 with both of them because both the 100x squared and the yz to the 5th were in the root to start with. They were both 1/3, this 1/3 exponent belonged to both of these, so it should go in front of both of those. Next, I noticed some multiplication happening here, so I changed that to addition. Notice I still carry the 1/3 in front of everything because they all belong to the 1/3 exponent. I also, when I changed this to addition, I was careful about putting parentheses here because I'm subtracting this whole thing. Because both of these are in the denominator, that means the whole thing is being subtracted. So then I can distribute this negative and have them both be subtractions. So basically what we're saying is if it's minusing, then that thing should go in the denominator, y and z to the 5th. If we're adding, then those things go up in the numerator. Then the second to last thing I noticed is I can take this exponent in front and I multiply it with the one that's already there. So 2 times 1/3 is 2/3. And 5 times 1/3 is 5/3. Now, there is actually one more step I can take to simplify this. Remember, anything that's all numbers, we can type into our calculator and see if it's a pretty number. So if I type that one into my calculator, I'll notice that I actually end up getting a really nice fraction of 2/3. So I'm going to change that to a 2/3 since it's a nice looking fraction. And that is my final answer. Now let's go to example 9. This one's a different kind of problem. Example 9 says use the properties of logarithms to write the following as a single logarithm. So this is a condensing problem. Whereas before we took one log and expanded it to multiple logs, now we're taking multiple logs and condensing them to a single log. So we're going to be doing all of our rules backwards. So let's start with A. This 2 in front, I'm going to move backwards and make it an exponent. Same with this 3 in front. Go backwards and make it an exponent. So now I have log of x squared minus log of x minus 1 cubed. Next thing I notice, I've got subtraction between the two logarithms, so I can turn that into division. So divided by x minus 1 cubed. And I have officially condensed those multiple logarithms I started with into a single beautiful looking logarithm. So that is it. You're done. We're going to do the same thing on B, where I'm going to get you started and then have you pause the video to see if you can finish it out on your own. So to get you started, I'm going to, zoomed in a lot right there, have you look at this 1 over u. This is a fraction. We don't usually like to deal with fractions, so I'm going to put that u to the secret 1. And the first step I'm going to do is bring that u up and make the exponent negative, using our properties of exponents. Because then that way it's not a fraction anymore. It'll be a lot easier to deal with. Then I notice that I can take this negative 1 exponent and put it out here to make it a subtraction. So now I have this. So I would like you to pause the video at this point, work through this problem on your own, and then come back when you're ready to check how you did. Let's see how you did. So here I have, we got to this point where we moved this and made it a negative. So next thing I'm going to do, I'm going to move the 4 in front to become an exponent right there. Second thing I noticed, these are both subtracting. So like we noticed in this last problem, if they're both subtracting, they both go in the denominator. So I put the 5u in the denominator and the u in the denominator. Combine those, 5u times u is 5u squared. Now, at this point, you can keep simplifying. Because these are the same base, we can use our properties of exponents, which says if we're dividing, we subtract the exponents. And I brought the 5 out as a 1/5. So if I subtract those exponents, I get 1/5 u squared. And that is my final answer. So that is all we're going to do today for our properties of logarithms. In the next video, we're going to talk about solving logarithmic equations a little bit more.